All right, ladies and gentlemen, we are starting Unit 2. Unit 2 goes from 1.7 and 1.8 all the way through Chapter 2. The reason I separate a little bit is there's so much from 1.1 to 1.6 that it's easier just to separate these other two. So 1.7 and 1.8 both work very similar with each other. Okay, they are all about inequalities. So we are going to go ahead and get started on this. So let me go ahead and share my screen. Share my screen. Let's get, hold on a second. That's not how I wanted to share. Let's see here. That's not going to work. Hold on. Let's do this way. There we go. All right. So we are going into sharing my screen. Yay. Always an interesting rule. You got to have everything on at the right time. All right. So we are talking about inequality. Now, these are things most of you guys are going to know right off the bat. Okay. Just fresher for some of you guys who might not have done math in a while. Okay. Might have forgotten how to do some of these, just symbol wise. All right. So your inequality symbols. Okay. Because equations, of course, have that symbol. Okay. So inequalities have one of these symbols. So I can either have a less than, I can have, whoops, sorry, I have greater than, I thought I did them the other way, greater than, this is less than, this is greater than or equal to, which can be either bigger or the same, right? And this is less than or equal to. All right, so symbol wise, okay, if I wanted to compare 5 and 14, I know that 5 is less than 14, so I put that symbol. Okay, I know that negative 8 and negative 8 are the same, so I put equal to. And then here, I know that negative 18 is actually bigger than negative 25, so we put that symbol. All right, so those are our answers to those. Okay, now wouldn't it be nice if I gave you a whole test like that? But sorry, no. All right, now one of the things I do need to make sure you understand is the following. All right, how do I put this on a number line? How do I put numbers x that are greater than or equal to 4? Okay, so the way we deal with these, okay, if you remember back in the day where you did number lines and stuff like that, you might have used like for greater than or less than symbols, okay, these are what's known as being open, okay, and you would use a circle, open circle, to show that point, right? You also would, if it was with the line underneath of them, we would call that closed, okay, and you would use a filled in dot. That was a way a lot of high schools and elementary schools and middle schools would do that, okay? So for 4, you would put a closed in circle, and if it was greater than, remember, number lines go left to right, bigger, so you would do an arrow this way, okay? Same thing for 13. If it was x is less than 13, we put an open circle, and you go this way. Now I draw it above the line so that you can see it and it doesn't get all messed up, okay? Now, you can actually use that on WebAssign, but the other way they do have it, which ends up being maybe, I don't know if it's easier or not, okay? We have what's called interval notation, okay? And in interval notation, if I have something that doesn't have a line under it, we use parentheses, okay? If it's closed, they use brackets, okay? And interval notation always goes least to greatest, and that would be left to right, okay? And so in a number line, they might show it like the following. Instead of doing the dot, they use a close, which we call some will call it a hard bracket. And you would do a hard bracket like so up here, and then you draw your arrow this way. And And what you're going to be doing on the WebAssign is that's an option that you can use. Okay. If you were going to do this one, which is closed, which is open, which we also call a soft bracket, you would do this here, from here to here. Okay, like a little parentheses, and then it would go with the same arrow. Okay. Now, the way we would actually bring down here and show interval notation, if I give you x is greater than or equal to 4, the interval notation would be a hard bracket of 4, and this arrow, when it goes to the right like so, that's known as positive infinity. And so we would go from 4, include it, all the way to positive infinity. Okay? However, infinity is always considered open. Okay? Infinity is always considered an open. So you never use a bracket. You always use a parentheses. Okay? Now what if I had the other one, which I gave you, was x is less than 13. So if you go here, notice if the arrow is going to the left, that's considered negative infinity. So you would go negative infinity all the way to 13, but 13 is not closed, it's open. So we use parentheses, and then we always do a parentheses around the negative infinity. Okay, so you with negative infinity, it's always open on it. Okay, positive infinity. That's what people hate doing. The infinity is always open. Okay, so that's how you would do interval notation for these. All right, so let's put this into action. Okay, and we're going to solve some inequalities. Okay, most of the things you should remember. We're going to solve an inequality by isolating the x, or the variable. Okay, so we got to isolate the x, which means I'm going to add 5. Now if I add 5 to the other side, everything's copacetic. We go 3x is less than or equal to 13. Okay, and then we're going to divide both sides by 3. Remember, we like our fractions, so it's x is less than 13 over 3. Okay, I can put that on a number line. Here's 13 over 3. Now, because it's less than, it's got an arrow going. It's going to be from here, and it's less than, so it's going to be open, going this way. Okay, I could use the parentheses, open, going that way. And then interval notation, we'll say interval notation, it's going to be negative infinity all the way to 13 over 3, both parentheses. Okay, so that's how you would normally solve all of that. Okay, so let's look at the next one. Same thing. We got to get rid of the 14, so I'm going to subtract 14, which makes no difference to my symbol. And we're at this step here, negative 24. All right, so now we got to get rid of the negative 6. We're going to divide by a negative 6. Now, this, if you remember, back in the day, you should have learned that that's going to be x. But anytime I divide or multiply by a negative, this becomes greater than or equal to 4. It flips. And the rule is multiply or divide both sides by a negative. You flip the symbol. Okay, so this gets flipped, so I get x is greater than or equal to 4. So I'm going to go here at 4. A 0 would be over here, right? So this would be a hard bracket to the right, or a closed circle if you want. You can do the closed circle. I still think they give you that option. Okay, and then we're going to make this an interval notation, which is hard bracket 4 all the way to positive infinity. And there's my interval notation. Okay, now rules still apply for everything. Okay, same old rules. I still have to distribute. So if you look at this problem, 2 times x minus 5 is greater than or equal to 3 times x minus 8. We still distribute. 2x minus 10 is less than or equal to 3x minus 24. Okay, and we're still going to solve this the same way. Okay, now there's a couple ways you can solve this to isolate. It is up to you on how you want to deal with this. Okay, I do know, and I'm going to show you a different way. I'm just going to get my, I'm going to subtract the 2x just to see what happens. We're going to get x over here. I want to show you some stuff. Then I'm going to get the x isolated by adding 24. And so I'm going to get 14 is greater than or equal to x. But what I want you to notice or understand is that can also be flipped. We can switch everything. X is less than or equal to 14. I flipped everything. This putting the x on the left side just helps on graphing, because when I graph this, here's the 14, here's the 0. It's closed at 14 going this way, which allows me to write my interval notation at negative infinity to 14, hard bracket around the 14, and parentheses around the infinity. Okay? So you can flip the whole thing as long as you flip everything, including the symbol. Switch sides. All right, so what about fractions? Fractions are great, okay? If you can still do the same rule of getting rid of your fractions by, if I wanted to get rid of fractions here, I'd get a common denominator or common LCD, right, which would be 6. So multiply everything by 6, okay? Now, how do I deal with that when it's in a fraction? Well, when this multiplies to the 2, that's going to leave me a 3, right? 2 goes into 6, 3 times the x plus 8 is less than x minus 9. Okay? So now I distribute. 3x plus 24 is less than x minus 9. Do your algebra skills. It's 2x. Subtract the 24. We get negative 33. And so x, whoops, there's a less than symbol. Less than symbol. Don't forget that. That you can lose that pretty quick. Negative 33 over 2. Now, I didn't ever divide by a negative. I never divided everything by a positive. Or I didn't divide or multiply by a negative any point in time, so I don't have to flip the symbol. So if I wanted to graph that, I know negative 33 over 2 is over here. 0 would be on the right of that. That is an open circle going to the left. Negative infinity to negative 33 over 2. And everything's open. No line under it. Okay? Now, if you multiply this whole thing by a negative 6 to get rid of fractions, make sure you flip the symbol. Okay, so if you happen to decide, I mean, if you want to multiply everything by negative 6, which I don't know why you would do that on this problem, but if you did, you would have to flip the symbol in the middle. Okay, that would be part of the deal. All right, so last couple problems. Compound inequalities. Okay, I'm not going to do a lot of questions in this section for your homework. It's a very short homework assignment. We'll talk about it here in the last part of it, but you do have to know how to solve a 3-part inequality, which is pretty simple. If I'm trying to isolate the x in the middle, okay, then I would want to subtract the 4. I got to get rid of it. So what you do in the middle, you have to do to all 3 sides. Okay, so I'll simplify everything. That's negative 20 less than 2x less than or equal to 6. I'm going to divide by 2. Actually, let's do this. Let's actually make this a negative 2. Let's change the problem a little bit. We're going to change it up, see if you're paying attention. So we're going to actually make that a negative 2. All right, so I'm going to have to get rid of that negative 2 now. So we're going to divide both sides by, all 3 sides by negative 2, which would make this a 10, an x, and a negative 3. But notice how the signs have to change, both sides of it. So that means I do have to flip the symbol in that case. Okay, now this, remember I like left to right, lowest to highest? That would be the lower number. So we're going to flip it, negative 3x and 10. But when I do flip it, we flip the symbols back. And this would be less than or equal to and less than. Okay, and so this would be my inequality. Now, how does this translate to a number line? Well, here's 10. Here's negative 3. All right. At 10, it is an open. So I'll put an open here. At negative 3, it's a closed. And then we connect in between. Okay. This would be negative 3 all the way to 10 in interval notation. Okay. On your graph on the WebAssign, you can do it like this. Hard bracket, connect to a soft bracket. Okay. So that also works. So if you happen to have a negative in the middle, you multiply everything by the negative 2 or divide by negative 2. Make sure you split the symbol. All right, so let's look at this last one. I got a fraction here. So I want to get rid of that 2 first. So the first thing I want to do is multiply everything by 2. Same rule I do everything. Same, but everything gets multiplied by 2. Well, the left becomes negative 4, but I multiplied by a positive 2, so I don't flip it. The middle becomes just x plus 5 because it had the fraction, and then the end is at 12. And now I have to isolate the x, right? So we're going to subtract 5. Now that is not multiplying or dividing, that's subtracting. So I do not flip anything. And I'm left with this. Okay? So I have negative 9 is less than or equal to x, which is less than or equal to 7. This should always be the lowest number to the highest if you're using these symbols. Okay? If they're pointing to the left, the symbols are pointing to the left, it always be lowest to the highest. If they're pointing to the right, then it's highest to lowest. But it's easier this way. Now, how do I graph this? There's a 7, here's a negative 9. They are both closed and connected, which would be hard bracket to the hard bracket, or negative 9 to 7, both hard brackets. Okay. Now, as an FYI, I do know this assignment does give people fits when they graph on the WebAssigns. Okay, your interval notation is going to be worth more than your number line answers. Okay, so don't fret too much. I think every question is worth, like, I gave it a value of 2, so it's like 1.5 is the interval notation answer, and only a half is the number line, because if you miss just a little bit of half, it won't kill your grade too much. But it's more of just where it's at. So if you do have some issues with that, just let me know. I can fix it on your grade book or whatever, because I do know it's a very, very touchy. Okay, it's going to give you a number line. Okay, and then when you try to place the parentheses, okay, it sometimes it's very difficult to place. And if you do have trouble trying to place it, try one time just using like an open circle. Okay, or if you have trouble placing this where you want it, try doing a closed circle, okay, instead, and see if you can place that in the right spot, because it's just very picky of how you place it. So don't get too frustrated with it. All right, so I hope all of this helps. Okay, we want this to be able to be helpful for your grade, and I hope you're watching these, because I do give extra information on these videos, so just as an FYI. Okay, and again, I hope this helps, and good luck, and see you in the next one.